before we talk about weather services part 2, could you do me a huge favor and go in the description box and fill out the little Google Forms survey? I just want to know how this channel is doing and if you're getting anything out of it. Thank you. The first thing you see when you go to the AviationWeather.gov website is this overview chart. There are a bunch of things that you can turn on or off, but it gives you kind of a broad picture of the overall weather in the United States, or if you zoom in the particular area that you're interested in. Now we'll go through this one by one to kind of give you an idea of what some of these things are. The flight category overview tells you whether the conditions are marginal VFR, IFR, or low IFR. If you were here for one of my weather videos, you probably remember the definitions for marginal VFR, IFR, and low IFR. If not, here's a quick review. A SIGMET is significant meteorological information. There are two types of SIGMETs, either non-convective or convective SIGMETs, and this is weather information that is hazardous to all aircraft. The non-convective SIGMETs includes things like severe icing, severe or extreme turbulence, clear air turbulence, dust storms, and volcanic ash. And these things are not associated with convection or with thunderstorms. Convective SIGMETs are for hazardous convective weather. They are for things like severe thunderstorms with winds more than 50 knots, tornadoes, embedded thunderstorms, or lines of thunderstorms. So you need to be on the lookout. Now if we look here, we have a couple of convective SIGMETs, and you can actually click on one and it will tell you where that convective SIGMET is. A SIGMET is a WS, that's the letter for the weather product, and it was issued by the Kansas City Weather Center. It says it's a convective SIGMET, number 79 Charlie, valid until 2255, for Michigan, Wisconsin, Minnesota, and Lake Superior. And then there's a description of that area where that SIGMET is. So it says, from 80 miles north-northwest of Rhinelander to 50 northeast of Rhinelander to 40 west-southwest of whatever ODI is, to 40 south of Minneapolis to 80 north-northwest of Rhinelander, and it's an area of embedded thunderstorms that's moving from 230 at 40 knots, and tops are at flight level 440. If you were to plot those points, you would notice that they match pretty much exactly the SIGMET information that you see on the graphical display, and the radar kind of matches it too. For AIRMETs, we'll actually switch over to the G-AIRMET or the Graphical AIRMET tool, just because everything gets congested on that one page. On this page, you can turn individual things off and on. An AIRMET is airman's meteorological information. It's weather information that's of interest to all pilots, but potentially dangerous to light aircraft and those with limited capabilities. AIRMETs are issued for moderate icing, moderate turbulence, surface winds 30 knots or more, and areas of IFR or mountain obscuration. And they're labeled AIRMET Zulu, Tango, and Sierra. Zulu stands for freezing. For Tango, you can think of the dance, and if air moves around a lot, that causes turbulence, so Tango is for turbulence. And Sierra, like the mountains, for mountain obscuration and IFR conditions. And this is where technology is actually really good. You can look at the map and figure out where those AIRMETs are. So for example, looking at this graph, we can look at high turbulence and you can see where the areas of high turbulence are. You can click on any one of these and see what the altitudes are for the turbulence. Once again, AIRMETs are for moderate or greater turbulence, so the severity you'll see is moderate at the very least. You can also look at the low turbulence. Once again, you can click on them and it's from the surface up to whatever altitude. Next is low level wind shear. You can click on that as well. And they're saying airspeed loss or gain of 20 knots or more below 2,000 feet AGL. And that's low level wind shear in this area. We can also click on surface winds, and that tells you winds greater than 30 knots. That's the general description. For icing, there's an icing deal as well, and the altitude's there, and it's once again moderate or heavier icing. This is a freezing level. It's kind of hard to understand at first, but sometimes you have to move the map a little bit. Basically, where this line is right here, the freezing level is at 16,000. In other words, when you get to 16,000 where this line is, the temperature will be 0. So you know where to start expecting icing. Right here, the freezing level is at 12,000 as you go further north. The next button is for IFR, and there's a couple areas of IFR, and it tells you what definition of IFR is. And then finally there's mountain obscuration, and there's only one right now. Mountain obscured by precipitation clouds or mist. So once again, AIRMET Zulu is for icing, AIRMET Tango is for turbulence, and then AIRMET Sierra is for IFR and mountain obscuration. You can also click on these thumbnails down here, and that's a forecast going through. Each one of those is split into turbulence, visibility, icing, etc. And there's a nice chart right here for you to learn what all the terms mean. There's also this AIRMET plot chart that you can click on, and then you can select individual little things, kind of like we have been doing, and you can look at the forecast periods. Something else that we'll look at is this winds and temps forecast. You can look at the map and kind of click around to see where the winds are, and that's fine and all, but you actually need to know how to read the textual description of all this. Before we do that though, there's a nice little chart right here you can click on and see what the winds are doing at each level. So you can scroll through and see what the wind is at 3, 6, 9,000, etc. And as you notice at the very first couple clicks, there's no wind data in some of these areas, and that's because winds aren't forecast within the first 1500 feet of the elevation. So now what I wanted to show you is if you scroll down here to where it says winds, temps, data, you can click on any one of these sectors. Let's say right here. This is for lower altitude, and this is the valid period, and then the area that we clicked on. This is when the winds are valid, this is when you should use the winds, and temperatures are negative above 24,000. So now the way this works is each one of these is a station where the wind is observed, and these are altitudes 3, 6, 9, 12, 18, etc. The way to read the wind is the first two digits are the wind direction, and that's 270, and the next two are the wind speeds, 0, 7. So the wind is from the west at 7 knots. The next addition to the wind is the temperature. So the winds are 260 at 8 knots, and the temperature is 26 degrees. If you see 9900, that means the wind is light and variable. Also, if you notice above 24,000, there is no temperature sign, there's no plus or minus, and that's because temperatures are negative. Here's something to pay attention to. Let's say you were flying between this station and this station, and these were your waypoints along your route. Pay attention to the wind direction and the wind speed as you go along. Now I don't know where these stations are, they could be really far apart, but let's say that's what they were on your route. So you see that the wind changes from 260 to 300 to 270 to 240 back to 310. That's a potential for turbulence and maybe some wind shear. Also, if you look right here, the wind goes from 320 to 280 to 240 as you climb from 6,000 to 12,000. That's also a good indicator that there might be some turbulence as you climb. Winds above 99 knots are quoted slightly differently, and I couldn't find any in the United States, so I had to go to Canada's website. So this wind direction and temperature right here, it says the wind is from 740 at 9 knots and minus 42 in the temperature. That's because the way we code winds above 100 knots is by adding 50 to the direction. So the 74 you see over here is actually 240, so the wind is from 240 at 109 knots, because you subtract 50 from the direction and add 100 to the speed. So the wind is 740 at 109 knots, and the temperature is minus 42. And in case I forgot to mention it, 9900 is light and variable, or less than 5 knots. In the forecast tab we also have prognostic charts. The page looks kind of confusing, but you can go all the way down to the surface plot. On the prognostic chart you can see the highs and the lows. You can also see the weather troughs. On here it'll also show a tropical depression, and this is indicated by this little box. You also see little hurricane symbols if a hurricane happens to come by. With the Prog chart you can also scroll through and see what the forecast is supposed to be. On this previous page we also have a low-level significant weather prognostic chart, and we can click on that. Once again, it's a forecast. You can scroll through all these different things. You might see this on the written test. These used to be really popular back in the day. They might ask you what is indicated by the blue scalloped line, and then all you have to do is look down here and oh, look at that, it's a definition for marginal VFR. One thing I forgot to mention in the previous video is the TAF and the METAR page. Right here you can type in a bunch of different airports. You can type in all these different airports and you can click get TAF data, and it will give you all these data points for your cross country, for example, so you know what the weather is and all of them. Another useful tool is this graphical forecast for aviation, and it will list a bunch of stuff on there, and there's also a nice legend, and feel free to explore that. And one other thing is the aviation forecast discussion. These are all the weather centers that you can click on, and this is a more or less plain English version of what the weather is supposed to be. So this is it for aviation weather services. As always, come back for another video, and until next time, have fun, fly safe, and always keep learning. See you next time.